It wasn't that far in our past that we started to learn how to multiply binomials. And one of the strategies we used for that was this idea about FOIL, where we multiply the first terms, the outer terms, the inner terms, the last terms. And when we multiply those two things out, we usually got a trinomial. And a trinomial, and I have a whole bunch of stuff on the board I'll walk us through, but imagine that we at one time learned how to multiply x plus 3 times x plus 4. And when we did that, we got a trinomial, an x squared plus a 7x plus 12 with this very specific set of numbers. And so that was the solution was a trinomial. Well, what we're going to try to do right now is to lead you through a process of how do we start with a trinomial and go backwards to this factored form. We've learned how to go from factored to trinomial. Now I'm going to try to help you develop some strategies to go from trinomial back to factored. So in order to do that, let me draw your attention to a couple of observations that you may have discovered along the way using this example that I have right here. Looking at these terms, what do you notice about this x and that x? Where did those come from? When we multiply them together using FOIL, we see that we get that x squared term there, the x times the x. Another observation we looked at was what happens when we multiply the last term times last term. This 3 and the 4, well, that produced that term in the trinomial. And then lastly, the one that's a little bit tricky was what happens when we notice that when we multiply the outers and added them to the inners, a 4x and a 3x, and we got that term. So if you can kind of remember those observations that we've discovered over time, then what we can do is start to unpack how do we work these trinomials back to factored form. The strategy that I'm going to leave up here as we process through these is this. Let's assume I have a trinomial. Trinomial means it's a polynomial of 3 terms, where the highest one in our cases will be an x squared. And it also has a leading coefficient of 1. I know a lot of words. What that means is that there's just a 1 right in front of that x squared. Once we add a coefficient there, our strategy remains the same, but just kind of adds one more layer, one more step to the process. So we're going to try to get really good at these first before we add on that next step. So the first thing that I like to do is that when I see a trinomial, the first thing I like to do is draw the parentheses, and then we know what should be in these first two terms. All of these are x's in those first two terms, so just simply place an x and an x within the brackets. Step 1, we're on our way. Step 2, list all the factors of c, or the constant at the last term. List all the factors and have them on the side of your sheet somewhere. So for example, if I looked at this one and it's a 12, well, all the factors would be 12 and 1, 6 and 2, 4 and 3. Actually, that's not all the factors. Can you think of a couple more factors? Yeah, some of you guys are seeing what happens. What about if it was a minus 12 and a minus 1, a minus 6 and a minus 2, a minus 4 and a minus 3? When I multiply those together, I get 12 as well. In fact, a positive 12. Now, what we're looking at is we're just looking at positive integers of factors. And so we can find other factors. What else makes it 12? 24 and 0.5. We're not going to worry about those at this point. We're just looking at the integers as we do that. So list all the factors of c, and I probably should have wrote them out like that. So there's 6 different factors. My next step is I'm going to search out of this listing of constants that I found, or these listings of possibilities. I've narrowed the entire search down to 6 possibilities of what these other numbers could be. And I'm going to look for the ones that if I were to add them together, I'm going to get the middle term, which in this case is a 7. So which of these, when added together, make a 7? Well, fortunately, I don't have to look through the entire infinite universe of numbers. I only have to check these 6. And I find out that it's this batch right there. So I know that those are the only factors that make a 12, but when I add up, make a 7. So that's where we search for bx. And then lastly, check. Go back and practice some of our FOIL methods and multiply these two terms together and see, did your process really work?